Okay, question number 9. Question number 9 says, Josh rows 10 kilometers downstream with the current in 2 hours. On the return trip, it takes him 4 hours to row 8 kilometers against the current. You got tired to row all 10. Okay. Find the speed of the rowboat in still water and the speed of the current. So, one of the things we want to establish right off the bat is your distance traveled, so D, or distance, is equal to your speed multiplied by how much time it takes you. Okay? So in other words, you would have probably covered this in a science class. D is equal to S times T. Okay? What we're going to do is we're going to make two equations that deal with this idea. Okay? Josh rows 10 kilometers downstream in 2 hours. So the very first question. He goes 10 kilometers, that's his distance, speed, and time. The time it takes him is 2 hours. His speed is his speed of the boat plus the speed of the stream. Okay? So what we're going to say is let x equal speed without current. Okay? So his speed without current plus the speed of the, and let C equal current speed. And by current speed, I mean the speed of the water, okay? So x plus C, okay? In the second equation, he actually only goes a distance of 8 kilometers. He's rowing upstream, so the current is working against him. It's slowing his speed down, where in the other example, it was speeding him up. And it takes him 4 hours to do this trip, okay? So we've set this up with speed multiplied by time. Now what we need to do is I need to use the distributive property, okay? And we're going to distribute these numbers to make up two new equations here. So equation 1 will be 10 is equal to 2x plus 2c. And 8 is equal to 4x minus 4c. Now again, we have 3 different ways of solving this. We're going to copy these to the next page. So, quickly looking at this, again, we can use any of the 3 methods, graphing, substitution, or elimination, to solve this. Looking at this, which one do you think will be actually quickest? Elimination is probably going to be the fastest. We need to get, when we're doing elimination, the coefficients in front of one of the variables to be the same number. Then we eliminate it. So, in order to do this, I actually only need to multiply the very first equation by the number 2. When I multiply every number in that equation by the number 2, both of the coefficients in both of the variables will be the exact same. So equation 1 will now read 20 is equal to 4x plus 4c. 8 is equal to 4x minus 4c. Okay. Now, depending on which one I want to eliminate, x or c, I have to decide what operation I want to use to eliminate. I can add or I can subtract. Okay. Personally, I like adding. And if I were to add these, which variable will become eliminated? The c. Plus 4 plus negative 4 will eliminate them. So we're going to add these. 20 plus 8 is 28. 4x plus 4x is 8x. Okay. And 4c minus 4c is 0. Okay, so we can put in the 0. It's not really important. I'm going to solve for x now. I need to isolate the x itself, so I'm going to divide both sides by x, or sorry, by 8. And we'll get x is equal to, 3.5, that's right. 3.5. So what that means is the speed of the boat, we would make this a coordinate, The speed of the boat is 3.5 kilometers an hour. That's how fast he's traveling. What I'm going to do is I'm going to eliminate again, just using the other operation this time. That was equation 2. We'll use those same two equations. This time we'll subtract the two of them. When we subtract the two equations, our x's will eliminate. So 20 subtract 8 is 16. 4x minus 4x is 0. And 4 subtract negative 4 is positive 8c. We isolate for c. The speed of the current is what? So the speed of the current is 2 kilometers an hour. The speed of the boat is 3.5 kilometers an hour in this question. So we got, therefore, speed of boat, kilometers an hour, and speed of current, two kilometers an hour. Clearly we need to work, or I need to work on my subtraction. 20 minus 8 is not 16, it is 12. Okay? 12, that makes that 1.5. That makes a little more sense. There we go. .5 kilometers an hour. There we go. Now we got it. Okay, question number 9. I wanted you guys to read the instructions at the beginning. It says, for the following problem, write let statements for the unknown variables. Yeah, determine the equations 2 of the linear systems that model this problem. Do not solve. It may be helpful to use a table. You do not need to. So the question says, a small plane traveled 1,515 kilometers in 9.5 hours. Right? During the first part of the trip, the plane traveled at an average speed of 150 kilometers an hour. During the rest of the trip, the plane traveled at an average speed of 180 kilometers an hour. Okay? How long did the plane travel at each speed? So, we're going to set this up again. Let x equal time spent. Okay? Because remember, distance is equal to speed times time. Time spent traveling 150 kilometers an hour. Let y equal time spent traveling 180 kilometers an hour. Okay, so those are x and our y variable. So the time spent doing both of these. How much time was this plane in the air for in total? 9.5 hours. So the time spent traveling at 150 plus the time spent at 180 is going to equal what? 9.5 hours. Okay? Remember, x and y are measures of time. A little different from the previous question. X plus y is equal to 9.5 hours. Okay? Now what we need to figure out. So, next thing we're going to figure out is their total distance. We know that the time spent traveling 150 kilometers an hour plus the time spent traveling 180 kilometers an hour is going to be equal to the total distance. The total distance is 1,515. Okay? So I have equation 1 and I have equation 2. That's all the question wanted. Wanted the two equations and the let statements. Said do not solve this.